All right, so this is just meant to be kind of a preview of what I plan to make videos on and what just kind of an overall run through of what's actually going on these final exams. Because if you take a look at what you've been given and from exams that I've seen in the past, you see a very obvious pattern. So there's more or less 5 questions and you know the basic topics. So right now I have the fall 2018 and the fall 2019 exams up. So if you look at both of them, the first problem is a trust problem, right? Boom, straightforward. I know I'm gonna have a trust problem. So problem 2 on 2019 and problem 3 on 2018 are both beam problems. And if you look at what they're asking about support reactions, they're asking about specific expressions between 2 points, and they're asking for shear force bending moment diagrams, right? So that's also something that we can make sure we're preparing for. Another problem that you'll see something with centroids, moment of inertia, stuff like that. That's problem 5 on both of these exams. So those are the ones that tend to be like the same no matter what. Like I can almost guarantee you're going to get a beam problem that's going to look like the 2 on this exam. You're going to get a trust problem of some kind. You're going to get something about like area moment of inertia, right? So the other 2 problems that are on these exams. So this one, you can see this problem where we've got a frictional cylinder and then we've got like wedges and whatnot. With this, I would say that this falls into a category that involves frictions, like pulleys with friction, and then there's a chance of it involving wedges. Or if we look at the 2019 exam, I would say that this problem is similar to it. So we still have that cylinder where we're involving friction over the cylinder. But in this case, we're looking at this block either tipping or sliding, basically, when it's in equilibrium. So if we think about just the points that we got to make sure we're studying, we got to make sure we understand the tension around a cylinder with friction. So like if this is T1 and this is T2, how do we relate them? And then we have to understand the tipping and slipping problems. So when will this block slide? When will this block rotate? And which one will happen first? And then with this problem, we have to understand how do we draw our free body diagrams for wedges, right? What does the reaction between these 2 surfaces look like? And then from here, this problem is mainly just free body diagrams when we go through them. And then the last type of problem you'll see are, it depends on what you want to call it, but I would call them like 3D machines or 3D support problems. So you have this problem on the 2018 exam, which is about this hanging signboard. And you have this question on the 2019 exam, which is this smooth uniform rod. And the biggest things with these is determining what support reactions look like. So for example, the fact that we have a ball and socket joint here, what are the reaction forces? The fact that we have this rod leaning on the wall at B with that cable, what do the reaction forces look like at that point? If we look at the other exam, how do we define the tension forces coming off of here? And we would define them using unit vectors, right? Because those give us directions. And then also, how will we go about solving? So we know that we have our summation of forces, summation of moment equations, but how can we utilize those to our advantage in these problems? So just right there, that's basically what your 5 different problems are. You're gonna have a trust problem. You're gonna have something with frictions, cylinders, pulleys, and then possibly wedges, tipping and slipping. You're gonna have a beam problem where you're gonna have to find support reactions, probably expressions for a specific section of the beam, and then you're gonna have to draw your diagrams. You're gonna have some kind of 3D machine, 3D support problem, and then you're gonna have a problem about centroids, moment of inertias. So that's more or less what you're gonna encounter on this final.